As long as you don't collide. I put a list, I think it was at line 17 or something. I put a list. Please don't do these things. Okay. Don't assume PCI addresses. Don't assume sysaddress. Don't assume XML address. That's the reason I wrote those down, is because that's my job. So lib-centric, they can't think any other way. But yeah, what other hypervisor could there be? Which is fine. I mean, 90% of the there are
first. Does anyone have listen to yourself?
I was first of all, I was making up a number. Second, thanks for not even considering Power BI.
Well, I only know 2 hypervisors. That's a little bit expensive.
Yeah. So there's also there's also Power BI, and then there's like variations of the virtualness, right? But then there's the outliers like Power BI again, where it's completely like retrofit all of our thinking to conform
Okay, can we start the next topic?
Oh, sorry guys.
Yeah. No problem. So the next topic is the metadata standardization video. Okay. Oh, much less audience here. That's good.
Yeah.
So yesterday we talked about how to do the reprogram, right? We want to facilitate the reprogramming nature of FPGA. We said 2 things have to be done. One is the API to allow users to reprogram or load the bit streams onto target FPGA or target device. Second is about we need to put the bit stream somewhere somewhere, and then we have the ability to retrieve it based on some under some conditions. So we come up with some bit stream like the metadata that we think should be associated with those bit streams. This is not probably won't have much code for this feature, but I mean it's more like how do we define the things that everyone agreed on, right? So we want to utilize, because we in the context of cyborg, we want to put the stuff into Glance, put the image in Glance, right? So we want to utilize the image property table in Glance, which is basically contains like key value pairs. Like the key will be in the name and the value will be in here. So so this is the existing table. We just use that.
Some important is missing here, right?
Sorry?
Should we talk about what's missing here?
No, nothing's missing in this table.
I'm saying something needs to be added here.
No.
So
we don't want to add things to Glance, right?
The image metadata needs to say which device type it's compatible with.
Yeah, but we don't want to touch the scheme of the table. We add stuff, but we add rows to this table.
That's fine.
Yeah.
Yeah, we can add more. That's what I'm saying, right? Add more properties.
Right. That's right.
Okay.
I saw you were saying, well, we want to change the schema of this table. Like,
No.
We don't want to touch that. So this is the some key value pairs I come up with, right? So we currently we need these informations to be in the metadata, so that we can, during the provision time or during the reprogramming phase, we can find out what's the bit stream we need to retrieve from Glance. What is the bit stream name, the blender board shell ID? This is like the shell ID means if for instance you have 2 cases. One is you're loading a shell. Second is you're loading a PR bit stream. If you're loading a PR bit stream, you need to know what's the required shell that's the prerequisite for it. You have to know what's like the target shell. Whereas if you're just loading the shell, then you don't need this. This could be a null.
Isn't it kind of presumed as a kind of a shell in the first place? I mean, in many cases, that may be a shell.
Yeah, then you
assume that,
specify a shell UUID or the UUID pointing to the shell image or some identifier for the shell, right?
It's basically identifies which device is going to fit in, whether it's a shell
Right,
or
right,
whatever.
right. Just an identifier.
Right.
Yeah, right. And the versions and driver. Okay, so it comes to the driver part. So every time we load the bitstream there, in order for the application to use this function, we need to install drivers. So we specify where like this driver is stored on the file system in this key value pair or any place you want, right? It could be on some GitHub link or something, right? So you can put it here, and then
it kind of assumes only one driver though. The same bit stream depending on which OS you're deploying in the VM.
well, here's the trick. The driver doesn't have to be one single driver. You could have multiple drivers bundled together in this path, and then as we discussed yesterday, we just download this package, unpack it. There should be some installation script in there, along with the other driver files. Run the script, install everything, done. Right.
You need to also standardize the format for the driver files.
Well, I mean, I don't want to be too detailed about how the driver should look like. I mean, we could agree on for instance, the installation script should. Right.
So you also need to define the interface script.
Oh yeah, oh well, that for sure, right? There should be, for instance, you just simple cases. We agree to run script.sh, right? Untargeted, run script.sh. Some return code for the return 0 means all good. Return 1, some error warning. That we just agree on that, and then we run it, right? And then the driver, the vendor driver from cyborg, which is seen here, the vendor driver, because this from vendors for Intel or Xanax, right? You guys write your own vendor driver here. It's your responsibility to actually run those installation scripts, I think.
Maybe I'm missing something here.
Uh-huh.
I'm not sure what I'm missing, but basically deploying the bit stream in an FPGA in the host. We're running a VM, it's going to contain the user space code or whatever to operate that bit stream, the function. So the VM should have that necessary driver. So what does it mean to say that a package the driver here and getting it installed in the host? Should be inside the VM.
Not necessary.
Okay.
So inside VM is one of the ways to package the driver. You could also have what Intel has this. I can remember what
Bare metal case?
now there's a parallel virtualization. So basically, you have driver on the hypervisor on the host side, basically, and driver in the virtual machine that it could mimic a fake password, basically, but it's on the host also. So it's not necessarily just packaged within the virtual machine.
Yeah, it could.
It's not necessary. It's not required, right?
It's not required.
Oh, okay.
It's just whatever script you run to make it work.
Yeah.
Right.
Okay.
Yeah.
So it isn't required. So if you had in your guess, if you had a function pass through whatever VM, you can still have that driver, however that's provided, whether it's through an image or whatever, a machine pack or something, and that's where the user goes and gets on the Git repository.
So this is what goes on the host?
Those are going on the host.
Yeah.
Given a certain functionality of your, say if you had IPsec, you have IPsec driver on the host, and you have some VirtIO or something, I don't know what you have, but then you could install that special driver on the host.
Right. So it's not required. Just whatever. It's just a script to make it work.
Or if you want to install
Enablement script.
You can install VA.
Yeah.
Right. And one thing we're missing here before you move on is, I think we need a BS ID.
What's
A
that?
UUID for the bitstream. So the PR bitstream needs a UUID to match it to.
The UID should be just should be inside glance already, right? That because the glance table has multiple other stuff too, right? It has a UID associated with that image already.
No, but there's an actual image container in, like the PR is an image container, for example. That image container has a UUID.
You mean the PR? Well, you mean the shell, right?
Bitstream.
You mean the shell?
The actual, the user image. So
Well,
in Xilinx case, the XCL bin, right? That's a container that contains a bitstream. It's a PR bitstream. That XCL bin that container has a UUID. And there's some sort of mapping between the container UUID and the shell UUID.
So that UID is generated by Xilinx?
Yes.
Then.
So is the shell ID, right?
Well, shell ID, no. Shell ID here is not what
It's
ID.
on something, on
No,
the,
this shell ID also refers to another image ID. The shell itself could be an image, right? For instance, this could trigger I mean, I'm not saying it won't, right? Like you're loading the user is asking, okay, load this PR bitstream for me, and then you come here and say, okay, this PR bitstream requires a shell bitstream of this ID, and then I don't have that in my system, but maybe someday I can change the shells.
yeah, but isn't this something that it knows, Cyborg knows by doing its initial query of the devices, or no? Bitstream image metadata. I'm trying to figure out it, because on our shell, we have a UUID it's a register you can read from the driver. We can expose that UUID and say, here is the shell UUID for your FPGA.
But I mean, this this UUID is not generated by Linux though. It's the UUID in glance.
I think something is missing here.
I mean,
Okay, let me pull out the. Oh, damn it! I don't know how to use Mac. Damn it. Can I? Where's that ESC? Damn it. Oh, here.
say,
Oh, okay. What?
What do you want?
Oh, yeah, here.
so we need some way to identify the actual shell bitstream that's programmed on the FPGA.
Okay, so the image ID essentially.
Yeah, we can't rely on device and subsystem and vendor ID because those are two.
True general.
Yeah.
Even the glance image ID is not good enough because it's vary by operator. Every cloud will differs.
Exactly.
So you want to put your own bitstream ID.
Yeah.
Makes sense to me.
So I think Intel's using UUIDs, Xilinx is switching to UUID, which I'll just use UUID, agree on it.
Bitstream from UID.
Yeah.
Well,
PR UUID and then shell.
How to
stack,
enlarge
region
this?
UUID.
Sure.
And those things are then
How to make it larger?
Subsite. Then
Oh,
the
there.
question is that term shell UID is either restricted
This-
or misleading.
Sorry.
What you really want is
So that UID refers to this ID here, image ID.
glance image ID.
Yeah.
That's not good though, because glance image ID will vary by operator, right? And every time you deploy a different cluster, you go to a different image ID there. So what you really want is to say that this bit stream fits in that particular device or a particular region. So you want somebody to identify the device ID or the region ID.
Okay.
That's what it matches to.
Hmm.
So in the workflow, what I want to say is, I want this function like IPsec or some UID, right?
Right.
I want to say, I got this image, bit stream, I got this device type or region type. Do these two match? The answer that they are corresponding.
So that kind of UID is readable from PCIe power space, right? Or register space.
So it should come with the
maybe.
image. Because if it's just the shell, yes, you can take from that. If there is no shell, or if you got multiple regions in the same shell, you need that region's ID, which only the image synthesis will know about.
Okay.
Well,
You need to
this-
synthesize from that.
So that
Doesn't your driver expose that? Can't you query the UUID of that region?
But given an image, how do you know which one corresponds to? Yeah, I can.
That should be, well, the vendor is responsible for that, right? But Cyborg also needs a way to know that that image fits in that region.
right? So the bit stream image should convey the metadata saying which region synthesized for or which device synthesized for.
It does, but that's vendor data. That's our data. We can't like I have my binary, I have my container, right? That container contains everything I need to know, and my vendor driver makes sure everything works. If it's the wrong bit stream, it doesn't let me program. It produces an error. So that's handled at my runtime. But from a cyborg point of view, I need to know that the bit stream that's in Glance and the shell that I have attached to the VM, those are compatible.
Right.
And by shell, I think region and shell is synonymous. I'm just using Microsoft terms.
So we need to ask the user to fill in that UUID generated by vendors.
That's
The
a good
user.
idea, right? Basically, that's what whatever the image is generated, that image dependency on the device type should be expressed in the image metadata itself. That means it goes with the image.
But I just want to make sure the vendor has that, because we are not just talking one vendor here, right? We are talking about multiple vendors here. So,
Right.
so this is a universal thing you guys are doing.
Well,
Then in your case, it will be a shell ID itself, presumably, right? Basically, you're matching against the particular shell ID.
yeah,
It would not fit any other shell.
right.
Okay. In the case of Intel, will be whatever slot ID or region type or whatever that we call it.
Yeah, some unique identification.
Right. When you synthesize it either using SD Axle or whatever or Quartus,
Yeah.
you synthesize for a particular device type or region type.
Right.
That information should be already expressed in the image. You can't put any other means. It's got to be inbuilt. And cyborg will need it to do its filtering and weighing. The filtering and weighing process is going to say, you got me list of hosts. It does not have what I want. I need to pick a host which I can reprogram. And file is going to take its list of images,
Actually,
list of images and match both.
here's the thing, right? The reason I didn't put it there at the first place was I don't want to. Damn it! Did I close it? Sorry. Tiny. This one. I don't know how you guys survive with Mac. I mean, I'd rather use Ubuntu for that. So the reason I didn't consider that as the type of UID you guys mentioned is I don't want to put vendor specific things here because there's this field in here. I think it could be vendor specific.
The topology. Wait, which
Yeah,
one?
the topology here. This is a clock, right? This is just a tax. So what it does is it could be any format. I just give an example. This is a JSON format, right? This tells what would be happen for the device after this bit stream is loaded. For instance, this describe if this image is loaded, there will be two VFs and a PF. Sorry, this is a typo here. So there will be two PF and two VF being generated, and this tells you how this PF and VF will be structured. Right? This PF will have one VF associated with it, and this so does this one. So this kind of this topology information will be stored in here, and these will be really specific to this bit stream, to the vendors, to you guys.
Yeah.
And the vendor driver's responsibility to parse this file or this string, and then populate, and then report it to the resource tracker upstream.
I think cyborg will need the IDs actually. I'll tell you why.
But for that, I mean, we could put ID in here because it's really vendor specific, right? We don't need that ID. We don't really need that ID when we're trying to find a fit resource for the user.
Oh, the filter and the way we talked about just a few minutes ago, you need the information, right? You got a list of hosts. Let's say it does not have the function you want.
Right.
Now you need to find within the list of hosts which could be reprogrammed.
Mm-hmm.
To do that, you need to say this function is being asked for. It's expressed by that image and matches that region. So image to region matching should be available in database in some form.
Right, but speak of that though, if you're, for instance, so for each, okay, so for each image here, right? Each image here, they should have the UUID from the vendor. It's called a vendor UUID, right? And this is generated during synthesized time, right?
Mm-hmm.
And then
This is vendor UID talking about the bit streams UID.
well,
UID
well, I
which
mean, this is not vendor UID, it's like the UUID generated by vendor
okay.
Right.
For the bit stream.
Mm-hmm.
for the district.
Okay.
Right. And then you have the UUID, the glance UUID when you store stuff in the glance, right? That glance generates one of the UID for you, right? That's right. UUID. One thing we could do is like when we do the matching, right? It's when we store a shell district in there, we will once we store in the class, we will have this UID and this UID, right? And then when we try to load the PR district, we look for it should have the prerequisite of some shell UID from vendors, which is this guy.
Again, shell UID means whatever device type or region type it matches. Is that what you mean?
Yeah, that's what he means.
Yeah.
Okay.
So and this two pieces should be the same, right?
It's yes, that should come from the vendor. That's
Yeah.
right. Yeah.
Right.
Yes.
So that's the region UID.
Right. Yes.
So given that, what if we just ask it to look for this guy instead of this guy? Because this guy is too vendor specific. I don't want to put it in a glance database.
This is the property of the image itself, though. Whoever provides the image to you is giving you all the information. There's
Okay.
Yeah, I think it has to be, otherwise how do you know that it's, you know? Yeah.
Well, I'm totally fine putting it there. I mean, the thing more is it might not be the case in the future that maybe some other vendors that they just don't have this kind of problem.
Well, they need to. I mean, that's what we're saying is
right.
they need to identify
So
their
you're saying we
region.
kind of standardize this?
Yeah, we need to
so
standardize
force them
something.
to have that.
Yep.
Yeah.
Okay.
If you want to program, you know, an Intel bit stream into the region,
Mhm.
then you need to make sure that that PR bit stream matches the shell UID that they're providing when you query that device.
Yep.
Okay.
And
So
same
and
with
then
sound.
we should have some utility, right? We should have some utility to allow other people to upload their images, and this utility should force them to provide this kind of UID for the system. Because let's say right now you're uploading the bitstream is a manual step, right? And then there's no enforcement for like to force the vendor to write this information into the property.
It will be nice if cyborg can give an API to upload images, so that they can control what is coming in.
Yeah, then that too, right? Cyborg could have a because I talked with Xiaohe last time that I think we kind of agree that we should have some utility outside of glance,
Mhm.
probably in cyborg, and then which cause glance as a part of this process to upload the images, but also enforce some of the properties that has to be associated with this. Image.
Yeah, I mean, you need PR verify or whatever.
Right,
We're
right.
talking about IP. What was IP? Scan before IP repo.
Right, you can do some scan.
Yeah,
Right.
okay. But then I think that it's not the responsibility of, I mean, the vendor has to expose the UUID. I don't know, okay, so maybe the vendor driver. Are you saying the vendor driver for Cyborg needs to write that UUID, the vendor UUID in there? You're saying when Cyborg enumerates the devices in OpenStack, it gathers the UUID and writes it in. Like,
No, but that's the resource. That's the resource tracker. I'm talking about how to upload the image.
well, so
Because uploading images has nothing to do with resource tracker.
so when you compile your when you build your bitstream, you have to provide some device that it's built against, right? Some
Yes.
region it's built against.
Yes. That has to be provided by the image provider himself. When you do upload, the image has to provide information which region or device built for.
Or it's provided at ingest time.
I'm sorry, what's
So
that?
when you're actually when the API to add that to glance can have that data.
Yes. By the time it gets into Glance, the property should be present in the image.
Did it?
Not metadata.
So what you're saying is we have some API here for uploading the image to Glance.
Yeah.
This is Glance. And there's another path to inject the metadata as well.
Well, when you upload it, you need to provide the.
Well, yeah, user provide all the inputs here, right?
But they need to just explicitly say here's my bit stream, and here's the shell, here's the region it's supposed to go against.
Right.
Now, however you check that, whatever, but there needs to be a way to check that. In order to check it, you need probably the shell. And you could do a binary diff over the, you could do some diff to make sure
Well,
the
you
wires.
provide the shell UID.
Yes, you have to validate the binary. And so you need to know the shell. I mean,
That's
so you also need to know that.
Well, that's another. I think that's totally another process.
I know, but the data needs to be there, right? Somehow. So that's why I'm saying the BS ID needs to match that, right? Because if you have a BS ID of the shell ID, then you can go, oh, this ingest UID and this BS ID are the same. I'm going to check these two in my ingest process.
one thing I'm just not going through all those elaborate steps is to say the image should have metadata, the whole thing should be checksum or have signature on it. You just verify the signature, get some certificate chain or whatever. After we know the image and the associated metadata are together. So from its provenance, right, amount of creation is always bundled together and can't be tampered with. So instead of having to go through a verification process in OpenStack at the moment of uploading, you kind of trust it based on the signature and certificates.
I don't think any vendor would be willing to do that. Could be temporary. They're building their own shell. They're building their own shell, region, whatever.
Okay.
And they're the only ones that have that. That's an encrypted bitstream. So when a user builds against it, they only see, the I/O, and that's all. So
then this could be a two-step process. The first step is simply to get it in the Glance in some form. Second step is to verify that what it says actually is correct. Like you said, it's a validation step or verification step. You actually try it out, make sure it works before certifying it to be valid in Glance. If you try to couple both, the problem is this: you got one API is trying to do a lot of different things.
Wait. So I think we should back to the topic. Right now we already generated this bitstream, right? Binary.
which one, the user or the shell?
For both of them.
Okay.
So right now we assume this bitstream is ready, and it is trusted. Right. We assume this already been checked. All those. And there's a physical file there, you need to upload it on Flex.
Okay.
So you upload it, you write the metadata. That's all. I think that should be all. Okay. And then to check if this is valid or legal, right? That's another process. I think that's totally.
Well, it shouldn't be able to enter the glance database unless it's checked. You shouldn't have bad bit streams in the glance
Well,
database.
that's the operator. Right? Operator just gather all the bit streams.
Since your concern, it's a valid concern. Maybe one way to do it is say get into glance first, but don't mark it certified.
Yeah.
Once you go to the validation step, then put an additional flag on the image saying this has been certified, and only certified images could be deployed.
Okay.
Right.
So say there's no certification right now, and the user can just upload it into glance. All right. So now you have a bit stream there. It has some vendor UID vendor metadata, right?
Mm-hmm.
And that indicates which region it can be programmed into. Is that correct?
Right.
Yes.
Mm-hmm.
Okay.
And it's also some kind of function ID, because for example, let's say I'm creating video transcoding RTL, right? RTL, and it synthesizes it for two different devices.
Right.
The images are different, but the function is the same.
Well, then you could defer it in the bitstream name or something, right?
The bitstream name.
That's why I think you need a bitstream UID.
But they're two different images. So
No, they're two different images. Fine. You upload it. Once you upload it to Glass.
Yeah, but how do you differentiate between the two different images? That's the thing.
Well,
They could have the same or different shells.
Right.
Have the same name.
Mm-hmm.
You need a UID for that bitstream.
Yes, something indicates function, which comes again from the image created.
you're talking about what it does, right? Talk about what this could do, right?
Right.
Then it will be in the top, like in this cloud.
Well, no, because well.
No, it would not be. Well, you can ask for it in the flavor, right? In the flavor, if you say that I want function ID X, it could match either this image or that image,
Right.
whichever maybe the reasons that they get programmed to.
Yeah, but the thing is, the moment you load this bitstream, let's say it gives you 4 PFs, right? And then this 4 PFs does 4 different things.
Well, I think we understand what the cloud is doing.
Yeah.
It's describing what's going to happen to the hypervisor.
Right. So in that case,
Whatever.
there's no. If you want to put those into those properties, it will be.
But there needs to be a way for you to say, I want this image. I want this, and this image is my function.
Mhm.
And I need a unique identifier that I can put in
Well,
that flavor if I want. And that function could be the shell, or it could be the PR bitstream. And if it's the PR bitstream, then that metadata needs to have a shell ID that says this is a prerequisite to me being flashed.
Yeah.
So any resource you grab needs to have this shell ID.
Yeah.
And if it's a shell, it doesn't need a prerequisite because it's just going to be flashed.
Then we could
generic.
just put it here, right?
I think it needs to be another entry
Another entry, yeah.
because you could have multiple shell IDs actually. Like one bitstream could be programmable into different shells.
Right. Okay.
Maybe not.
Oh, okay. I see your point. So we have an ID represent itself, and an ID represents parent. Like
Exactly.
The
The ID
prerequisite.
represents parent. Yeah.
And then the prerequisite could have its own prerequisite as well.
Yeah. Or it could have none. If it is the
Oh,
parent,
yeah,
then let's just say, just put me on this FPGA device.
Yeah.
The key is to recognize that two images may express the same function because they're coming from the same RTL. So the image expresses which function it represents. You can ask for the function instead of asking for a specific image.
Right.
But the user gets more flexibility. If you don't get this image, you get the other one.
Right.
Which is corresponding region for that.
But that's in your flavor. So then you can define
flavor.
2 UIDs. And then the resource, so you can define 2 bitstreams, right? Identified by the UIDs.
Yes. Two
Then when it
images.
goes to place this thing,
Uh-huh.
it goes, okay, I'm going to check to see if I have this shell,
Right.
this parent UID.
Right.
No, I don't. I'm going to check to see if I have the other one.
Other one,
Yes,
right.
I do.
Yes.
This is the one I'm going to schedule.
Exactly.
And then cyborg can say, okay, I'm going to program this.
Right.
Well, it doesn't make it complicated. How does it know?
It's all internal to cyborg.
Yeah.
Nova's not even touched.
Yeah, I know.
Nova simply says, here's the UID function I want.
But
All
that's
the-
another level of intelligence, right?
They're just checking the
Because right now, what we want is really basic, right? We want program this goddamn bitstream on here,
If you're talking
do it or fail, right? We don't want it to be that smart yet, right?
But it needs to be because it's the only thing in between.
We could add another layer on top of it. Right?
Yeah.
Given this feature being implemented, we can have another wrapper on top of it to try and fail, right?
we need to define the end goal. What fits in Rocky, what comes in ESO, what comes in T, so secondary step, right?
Right,
First, we need to define where we need to get to.
Yeah.
And where we need to get to is ask the function or image or device. Right? Any of those. User could ask any of those categories.
Yeah,
What we have to wind up doing in Rocky will be some subset of it, that's fine.
right.
So just to break it down again, the vendor ID on the host will actually go and try to program the bitstream. If the bitstream is like physically incompatible and it fails to check, it will just fail the program.
Yeah.
Right. But we actually don't want to be caught in that situation. Because cyborg should have already checked everything it could, unless the user is deliberately trying to tamper things and spoof UIDs and stuff like that. So that's the last fail-safe.
Right.
But cyborg, should everything be right and nothing be tampered with or mistakenly put in, it should be able to determine what the bitstream ID is that the function represents, and what parent it's able to be programmed onto.
Right.
Then it requests the parent, right? Like it requests the device or some FPGA with the parent function on it. It could be one, which is easy. Then it just, okay, it's one, so just program. Send it to the vendor driver to program, and then onward. But it could have two, right? You could have multiple FPGA devices that are also compatible. And then it needs to go back and needs to return, I got this device. That's when cyborg needs to determine when to program, like what bitstream to program out of the compatible ones. I mean, that's more complicated. I'll accept that. I hadn't actually thought of this until we started on this. Functional thing.
I see. Okay.
I was thinking like one shell, one bitstream.
Okay.
But
Typical synthesis method would be like you write RTL1 do multiple synthesis, right, for different devices.
yeah, but we're getting to a day and age where we're going to have shims, and the shims can make it so that you can reprogram bitstreams.
Okay.
Fixed pin placement. So
you
that's
mean-
not always the case, and you may have two functionally identical bitstreams that are physically different,
Exactly.
and that's what you need to protect. That's the naive case that you just need to protect.
So what you're saying is, one giving the same bitstream, like PR bitstream, it could be loaded onto multiple
No,
different
given the same functionality, the same code,
functionality.
you could have two separate bitstreams that perform identical functions,
Okay,
fit into different devices,
right,
and therefore require different parents and a different selection process.
right.
So what's returned by the actual Nova to the cyborg may be one of a few options that initially went out as possible candidates for placement. Is that right?
Yep.
So we need to guard against that. Whether or not we implement that today, okay, that's fine. Like the shell ID, that's fine. We can have a multiple shell IDs, right? That's already, you can already handle it, right? But we just need I think we need a bitstream ID field.
Yeah.
So that we can.
We can totally, yeah,
Okay.
I will add it there. But regarding the function, right?
For one bitstream, you only one shell ID, or one device ID.
One bitstream.
Yeah.
Right.
So I mean,
You have two bitstreams, both implement the same functionality, but each one goes in a different device or different region.
Yeah.
So you go 1-to-1 between bitstream and what he calls shell ID, but many to one between functionality and the bitstreams.
Well, that makes it simpler.
Right.
I'm actually thinking ahead
Oh,
of you
right.
onto the shim idea.
I see. Okay.
But we don't necessarily have to think ahead like that. Okay. So, but if you're multiple functionalities, you're thinking the name remains the same. The UUID for the bitstream is different, and the parent is different. So it's a one-to-one
Parent is
with the same
different.
functionality.
There will be another UID indicating its function. Some function UID is given by the developer himself. As part of the synthesis process, we enter something in there. It could be UID name, whatever can come or something. So that way, write your RTL once, go through multiple flows, replacement of each of the devices.
Yeah.
You got a bunch of bit stream, all doing the same thing though. You
Yeah.
synthesize for different devices.
And how, in the case of the NOVA of the resource mapping,
Mhm.
would you then how would you describe different bit streams with the same functionality?
So
The custom.
as far as NOAA goes, what we decided just now is that you only ask for a device type, and the function or image goes to extra specs.
Hmm.
So NOAA looks at a device type and finds all the portions that are matching device type.
Mhm.
Then comes some filter or where, which calls into cyborg. Cyborg looks at the extra specs. Okay, you're asking for this specific function or this specific bit stream or whatever, right?
Mhm.
It then filters it further. Given the list of all FPGA device types X, which one already has IPsec functionality. So it actually filters it based on that and returns a smaller list. That then goes to the weighing process, which may also potentially call into cyborg. Cyborg may again say, okay, among all these things which are IPsec, I want to use that one. That's higher rank than this one. So you have multiple hook points. Cyborg could choose to be a no-op in some cases, it's up to us. But we got the ability to do all of these in the standard scheduling process.
Okay, so I think that's the shell ID though. I think the functionality in that case, I mean, we may have to diverge a little bit.
Because
Different vendors.
because
I mean,
the
I don't know.
functionality itself could be described differently, right? If it's a IPsec accelerator, or it's a video decoding accelerator, or it's a machine learning accelerator, whatever, right?
Mhm.
Like, the function itself, description is like very complicated. Could be measured in different metrics, right?
Okay, at the end of the day, you wrote one RTL for that, right?
No, I'm not talking about RTL, right? No, I'm just talking about we giving the analogy, right? So we have a cup, right? We're filling water, Coke, or biscuit, right? Now, for instance, this cup is just good for water, right? And then we have the wine cup, right? So wines or whiskey, right? So now the water has a prerequisite for this cup, and then the wine has the prerequisite for their own cups.
Right.
Right. The thing is, the metric is different. Like, you measure the water is probably in how to describe this.
So, I mean, we're covering multiple use cases here. This is what makes it so hard, right?
Mm-hmm.
So there's the pre-programmed use case, and I am abstracting this away, right, for my own comprehension, right?
Mhm.
So in the pre-programmed use case, I think of it as a shell, right? So you are going to have a persistent bit stream on this thing. It does IPsec, right? But it could also just be a shell that accommodates another bit stream.
Mhm.
Is that right?
Yes, right, yeah.
So it's up to us on how to use that. And we need to find a generic way to use that within cyborg. So when you ask for an IPsec, I may just want a shell. So you ask for IPsec functionality.
Uh-huh.
You give a description and UID of an IPsec bitstream or something, or an IPsec device, right, or something.
It got changed a little bit in the previous session, right? So you would still ask only for device type. You are asking for, let's say, FPGA class X. And the extra aspect to say, I want IPsec.
Yeah. But you're also saying that there is something pre-programmed with that IPsec.
Yes, but
Right.
for this flow, it doesn't matter. As far as NOAA is concerned, it's already there.
But then cyborg goes and discovers that,
Okay.
right? And then it uses it. It passes it, gives it to you.
Sure.
Right? But in some cases, it may go find the device, find some other IP,
Mhm.
and then that other IP can be reprogrammed, or not reprogrammed, but added to in addition to. Have a PR that happens to it afterwards. It's not an IPsec. It's half IPsec. It's another half of something or something. If you know what I mean.
The phone, okay. So cyborg underscore another device, which is already another pre-programmed activator.
Well, no, there's pre-programmed. That's terminal, like a terminal pre-programmed device.
Okay.
The cyborg discovers and passes through.
Okay.
That's one use case. There's another use case where it's not terminal. It discovers that it has a shell,
Okay.
and that this is a parent of something else.
There's an empty region inside, or empty device.
Right.
Okay. Just a blank slate.
And then cyborg needs to go, oh, okay, now I need to program this other thing in there. Or I could program something in there.
Sure.
Or maybe this terminal, I give it to the user. So
Sure. The blank slate itself will have some kind of ID. So
that's
ID
what we're calling the shell ID, I think.
Mm-hmm.
And it's not a blank slate, by the way. Like the blank slate is truly like there is nothing on it.
Not even shell. But it's
No
okay.
shell, yeah.
Okay.
And it's just you discover a device ID over USB JTAG or something.
Got an empty region essentially. That's what
Yeah.
it is. Like. It's just a region which is not occupied by anything yet. So that has some kind of ID itself. In fact, that's what it will match images against. And that itself could be a resource which the user can ask for. So just give me that empty region or whatever I want myself. So it could be a resource directly exposed, or it could be a container for programming an image.
Yes. Okay, yep. That fits the abstraction. Now, I guess the other thing is, go back to the metadata thing. I mean, I'm trying to figure out how we identify the functionality. So you are talking about like a functionality that goes inside. So something's in glance,
Yeah.
right? And you need to program it onto the device that you asked for, against the shell that may already exist, or the UID of that device.
So the bitstream has to express two things. One is what is the device type or region type it's built for. I think that's called shell ID here. Hopefully, I know the better name. That's the matching thing. It's the hardware against for which it's built. That's one thing. Second thing is what does the image do? Is it IPsec? Is it video transcoding? What flavor of IPsec it is? That's presumably some kind of UID, or it could be a string. It's whatever you decide it to be, but it just acts as a function of that thing. And the reason why it's distinct from bitstream itself is that if you have multiple bitstreams doing the same thing, for the reason I described.
Yeah, that's what I'm saying. Like, that's why I put into this one here, because it will be really specific to each of the VFs or PFs that generated by this bitstream, right? Because you're a single,
you only have
the
one.
functionality might be complicated.
I mean, assume it's one though. Assume it's not.
Well,
Let's assume it's one, and it does the same thing, but you can't just program that against the same shell, right?
what?
So you have the same functionality.
Oh yeah, that's totally
A very
fine.
simple cloud.
Well, this is the way that this is where you can find out what it does, right? This is where you can find out what it does.
But cyborg needs to know about it. If it's totally vendor specific and opaque to cyborg, it would not work. The cyborg is actually using it in the filtering and weighing process.
Well, we could make it standard such that the cyborg knows, right? Well, this could be a JSON that's flexible enough, but is also standardized such that it can tell cyborg what it does.
Okay. Maybe I'm thrown off the term topology. To me, it sounds like interconnection among elements and then functionality or something.
Well, this is just a naming issue, but the reason I put the topology here is I want to describe how the structure will look like after it's being loaded, right? So have PF, we have, so you have after you load it, you have two PFs, and then each PF can have a VF associated with it, right? And this one does this one does AES, and this one does RSA, right? And they're doing different things. They have different capability, and it will happen after you load the string.
Yeah, but what if they do the same thing?
Well, then you just describe the same, right?
Yeah, but then how do you know that it's different?
What?
I mean, I guess by shell ID. I don't know. I guess so.
The
No,
same
no.
shell can put different things. Right? The
Yeah.
shell ID is not give you a functionality for the image that's sitting inside it.
but for itself, right? For itself, it should have an ID, like itself, right? It should have a ID that's generated.
Okay. Honestly, it seems to me that many lot of assumptions here. With shell and PF and VF, it fits certain model. The model is common today. It will work for now and Rocky release. As we go forward, we're getting a lot of requirements. Like don't assume PCI, don't assume this, don't assume that.
Right.
So we probably need to kind of increase the abstraction one level. We need to map it to PS and VS for today. That's still important. But we probably need to abstract a level where you're not tied to PS and VS alone in entire terminology. Right?
Right. So the problem we're trying to solve here is to tell cyborg what this image is for.
Yes. Okay.
Right.
Go ahead.
But the problem is this image, the capability of the image cannot just be described in the key value pairs.
It's think of it as UID for now.
Okay, well, it will have its own UID. That's fine, totally fine, right? It's like you can look up this UID, what it does by this UID somewhere else.
That's all we have for now. So there's better way of describing functions. We can explore them for the future.
Are you saying the cyborg would contain that mapping? What you
The image is supposed to contain that. Whoever created the image has to say this is the function UID for which I built it. The cyborg, if you're uploading some image to cyborg, you would not know if it's IPsec or whatever it is.
Right.
So whoever created the image has to say what it is. Yes, take two things. One is this is what the image does, which is the function on UID, and this is what the image is built against, which is a device type UID.
Yeah.
It needs both in the image itself. And
You're
once
saying
you
the
have-
device type UID is describing the functionality of it?
No, it's two different things.
Okay, so I'm going back to now, like you have separate flavors that have separate functionality, right? Is that kind of what you're thinking about?
Separate flavors or separate functionality. Yes, that's right. Okay.
So you have your flavor, it has a, what does it have? Some sort of ID for some sort of device type, some FPGA. And then in the extras, it has what you want to put onto it.
It's either a function ID or an image ID in the extra specs. I ask for a specific image or asking for a specific function.
So you would ask for a specific, so the way I think about it, you would ask for a specific image, right?
That's one way to do it. So,
But the problem comes if you ask for a specific function and there's multiple images, right?
yes.
Yeah.
So but because flavors are defined by the operator, that's a burden the operator could bear. You know what I mean? Like, does it have to? Because if we've added like this function, it makes it too hard. There's too many possibilities.
Yeah.
So let's say we have 3 images of the same function.
Right.
And they're all against different regions.
Yeah.
They used to ask for one of those images and it's not available, request fails. All are the equivalent thing is available in other regions which are available.
Yeah.
So the user's point of view, if he says just give me the IPsec function, and then the orchestration goes and figures out which is the matching image and matching regions can provide the functionality. That should really be the job of the orchestration.
So okay, so you have the device, right? Then on the device, it needs, so you're saying that it could have three UIDs for the same function, basically,
Yes.
in the extras.
Right.
This is one function UID. Just ask for give me this function,
Okay,
and then
so-
we translate
so
it to multiple.
Where
images.
is that translation? Who has that?
cyborg has it through this mechanism. When the image itself expresses that, cyborg has a list of images, right?
But this is
But it's not quite right though. How does the function map to the 3 different bitstream UIDs
Because
and
the image,
parents that it could be? You know what I mean?
the image metadata contains the function UID and also the device type UID for which it's built against.
Image metadata from where? From which image? Bitstream or?
Bitstream, yeah. I'm using the image in bitstream, it's not necessary.
I know, but then you're assuming that there's a standard metadata in the bitstream.
Yes.
We can't assume that. But Xilinx will use something else. We use XLN. We use a container format, proprietary container format.
As long as you put the metadata, it's fine, right? What is metadata standardized, not the image format or anything.
The metadata could be totally random. I mean, it could be anything.
That's why cyborg is standardizing it. Right? So right now, everything is
But cyborg can't standardize the metadata that we put in our container. So it can standardize the APIs, the UIDs, It can even ask for a bitstream UID and a shell UID, but the driver needs to provide that, right?
Correct. Okay, maybe okay.
But
I'm not saying that cyborg defines an IPsec corresponds to UID. That's still provided by the vendor. Vendor provides some function UID. He gives one UID, says this is the function. Cyborg does not know what it means, or it got this UID. Similarly, the flavor asks for a UID.
Well,
and it's
here's the thing, right? I mean, we couldn't determine what the user really wants. Like, for instance, the user wants a few ways the user wants, right? The real user might just want just this bitstream, load it for me.
Yep.
Right?
Sure.
We don't need to worry about anything else.
Right.
The other thing is user wants a IPsec, but he doesn't care what's the performance of this IPsec. He just give me an IPsec. Whatever is, I'm good with it. The other one is I want IPsec with KPI greater than 20 gigabit per second, right? These three are three different metrics, and then we couldn't predict what the user really wants.
That is correct. The user can ask for any criteria or any kind of functionality, but what the image creator knows what's actually in there.
Yeah, the image knows, but how does the image let cyborg know about this?
Through metadata, just like anything else, right? Just like putting UIDs for other things.
You're right, and then because these metrics are different, you just giving a key value pair table,
right,
couldn't really contain all this information.
Okay,
So that's why I put it into a JSON format and then store it inside of that field. And then we can standardize that JSON format such that the cyborg can look at it to figure out what it does.
I think it's also that JSON format as a sidebar. The two networking guys probably care about that.
Yeah.
Right? And they're not here, unfortunately.
Yeah, because I thought about just putting some extra key value pairs in here, but the thing is, it could be anything. Like if you have like 1,000, for instance, extreme case, you load the split stream, gives you 1,000 VS, right? And then you have to put 1,000 key value pairs, and then you don't even know how they structure to each other. I mean, how are they correlate to each other? Maybe first 500 belong to one PF, the rest of 500 belong to another PF.
Yeah,
right?
I see your point there. I'm stuck on something much more trivial in that I can't expect a standard format in my binary in my bitstream container. It's just like it's impossible. I can't demand that to people.
No.
Our hardware team.
Your image format, container format, whatever it may be, I'm not saying that should be standardized. But when you upload it, you're putting additional properties on top of that, right? It goes in the class.
That's also, okay, so that goes very back to my ingest, the ingest thing. When you're adding the image to the glance, right? Assuming there's no check or anything, right? It's unverified. You need to add that metadata.
Yes, exactly.
Yeah.
To it.
The cyborg upload API, you have to ensure that some metadata gets added to glance as part of upload.
In the right format.
Yes.
In the cyborg language that cyborg can
Right.
can understand, right?
And then it stamps it with the UUID, right? The glance UUID. And it also provides a shell UUID, which is essentially what is
prerequisite for this shell for this bitstream to load.
Right.
And that needs to be queried on, or that's found on discovery.
Yes, it should match what's on the system. Absolutely, right. Yes, right. But both are vendor specific.
Yeah. Right. Yeah. Because so you see my point why I put the cloud over there, right?
I see the point of the cloud. I'm trying to also understand how generally things would map, because there's half of the story is here, but I'm worried about the other half too.
Yeah.
You're like, okay, so this is how you have, once your image is there, this is what you have and how to get it there. But how do you get the image there, and how are all the stars aligned?
Oh, you mean how to formalize
Yeah, I mean, there's obviously an ingest API that needs to be defined here.
Yeah.
I'm just nervous not seeing it, even if there's no PR verify or anything like that happening.
We can, I can go back and write up another API just to standardize how. So it takes the input from the user and then translate it into.
Yeah.
The
I'm sure you will
format.
do it. I'm just trying to conjure how you would do it right now and making sure there's nothing, some random thing that's missing. I'm thinking. So I think that's it. So
So minimally we need that matching device or shell or region ID, whatever I call it. It's a minimum. Function ID, I see your point. We can think about it. If you essentially going one level even above what I'm talking about, you want to generalize it all the way up, talking about all possible function requests. That can get really complicated. We're trying to express all the functions in the world.
Yeah.
So that's like too high a level, right?
it's just on the specific image, right?
As for a specific image, or what you're saying is the image could be not just IP set, but IP set with, let's say, 2048-bit keys and this level of performance and that level of security and so on and so forth. How do you express all those properties? I condense everything to UID, and I think his point is that's not sufficient. You need to actually express it in more detailed form, right?
No, I mean you don't need to necessarily expose all those things. You just need to say, hey, this has 2 VMs and the driver. And that's essentially all you need, right? That's
a different level of information. Yes, you would probably need that also.
Yeah.
From the user's point of view, you could ask for a single image. I could say, just give me a function which may correspond to multiple images. I know different regions out there. I don't care about all those details. Find any free region, any corresponding image, just give me a function. That's all I care about. And your driver matches the function UID. So even though different images, it comes from the same RTL. So the matching driver can operate any of those. So that's all that driver to device matching needs to do.
Right.
So
and there's also the image, like the actual OS image, that you need to provide in this whole mess, right? That has all your dependencies in the guest.
In the guest.
To actually provide that, right?
Right.
And so that's something that we can also do, right?
I'm going to throw examples, could be totally wrong. You probably know this best. Let's take an example. Right? Let's say I write RT5P set. I synthesize once for, let's say, Xilinx Alpha Stage 7, another for Vertex. The same RTL, but implemented in 2 different devices, therefore it gives 2 different bit streams. I, as the image creator, am providing both to cyborg. When the user comes, he can ask for either of those. He doesn't really care which bit stream he specifically gets. It's both same thing.
That's a bit of but when you're actually creating the flavor, it gets tricky though, right? Because your flavor has 2 possible devices.
The flavor still refers to the function ID, which is done in the image, and the cyborg, which is matching the function ID.
So you mean
the
flavor define? Well, you have to define the flavor in such a way it will pinpoint a single bit stream.
Not necessarily. That's what I'm pointing
That's what
out.
he's saying.
Exactly. That's exactly what I'm saying. So the flavor asks for function ID. When it comes to cyborg says that I got all my images. I know which functions they correspond to.
Well, there could be multiple hits, right?
So
then you just pick one of them based on some metrics.
Right.
And
you could have a bit stream for VNIP, you could have it for View 7P, right? Different devices, different device IDs, different boards.
Whichever one happens to be free to speak the
right.
Right. You could make it as simple as complicated as you want. You basically got more flexibility, and you're not constraining the user to effectively pick a device. If you ask them to pick an image, effectively saying you can only use that one device, all the other one is free.
Okay, so, but it has to work the other way too. That's the thing, is it has to go the other way. The user has to be able to specify, I want to be an IP specifically, because my application is built for that, and I'm already planning this.
You mean ask for a specific image ID?
Ask for a specific
bitstream ID.
Well, there's vendor. Well, sorry, like the board ID, right?
Although in this scenario that you described, instead of having multiple different bit streams, different compatible shells, they'd be different shells.
Right.
You only have one. So instead of 1 to many, you only have 1 to 1, and then the problem is generically solved.
Right.
It makes it harder for cyborg, I think, because everyone's thinking right now, oh, you just ask for the device,
right.
and then you reprogram the bitstream on the device. And I see that, and that's what she's here to do. Yeah. But I also see your point, and it's getting more complicated to do, but it fits more use cases.
Right. Right.
It's a superset of this.
The lesser the user has to know about FPGA details, more adoption will have. Because generally, if you look at any of this community, like outside of FPGAs,
I
they think of it as
agree.
kind of a strange beast, right?
Yeah,
You want to remove all of this data
yeah.
as much as possible.
because you're talking about IPsec. This is something that may run on your undercloud, right? This may something that run on your infrastructure. Maybe the user wants it too, but maybe you actually want it in your infrastructure of your data center. That is another cloud.
Okay, right, yeah.
And then you could actually request these kind of features, dynamically. You know what I mean? And not necessarily requested by the feature and not by the device. I mean, I see what you're saying. And it also is like CRAN and all this other stuff, but
Right, you could ask
those
for
guys are going to want to do.
right. So giving the user flexibility to ask for a function or a bitstream ID or whatever,
Yeah.
it is qualified in some way in the extra specs. So I'm not necessarily saying you should do all of this right now.
You're missing the good stuff, man. I'm talking about your metadata for your networking.
Ooh, wow, probably should have been here for this.
That's all right. Okay.
I'll read the transcript.
We're gonna make it super extensible.
What transcript?
Isn't this session being recorded?
Yeah.
There you go. Is it? Oh, it's recorded?
Yeah.
Dang. So, okay, so is Cyborg willing to do this? I don't know if this is something that we have we fully thought through like this quite before. I mean, what will it take to do? Obviously, Nova has a lot to do on their end. I think they basically decided what they're going to do today, right?
From what I understand, they're not going to do anything at all, right? They already have everything defined. They're
Well-
asking us to fit into the existing model, right?
Well, I think for now, my proposal is instead of worry about the functions, let's just make that API work, which just takes very specific bitstream ID, just one-to-one mapping. That's already been done. User knows what they want. They come in and say, okay, program this bitstream for me onto this FPGA. Fail or success, right? So I mean, I think that's the first step, and then we can add some other intelligence level on top of it, all those stuff later on.
Okay. So are we focusing only on the Rocky release in this meeting?
Well, I
Because
think
it's
that's
not
right.
Rocky priority in the first place. So is this not for the future?
I think
You want to
this
define
is-
for the future?
I'm not sure what's the time frame for Rocky. Is this container on Rocky?
It depends on your volume that working
My
on.
volume?
If you can actively working on that, then we could put it as a rocky priority.
Well,
At least has a POC.
in my perspective, I want to make the reprogramming service ready in Rocky. That involves some API changes and some vendor driver stuff.
Yeah, we need those.
Yeah.
What are them?
I mean,
Good
I
driver.
hope I can make it happen. Yeah. Because we already make it happen in our own environment. Using our own solution, but it's kind of it's even simpler than this one.
Yeah. So how do we accomplish both things without too much insanity, so that we can build on it, right? So we have in our extras data, there's a UID
Mhm.
that represents the function.
Right.
Then Cyborg has maybe it has to translate that into the bitstream UUID.
Maybe provide another API just to figure out this UID for the user,
Right.
others. That we can split this work into two parts.
Right. So that we
So
can
this part just saying, okay, I already figured out what the UID is, and then we have another service just to help figure out what's the UID.
but the UID that we put in the extras data for the flavor
Mhm.
doesn't necessarily match to a bitstream
Well,
UID. There's some translation that
so the
happens.
stuff you put in vector stack for this flavor,
Yes.
you pass to Nova, and Nova pass to Cyborg, say, and then Cyborg somehow have some servers inside to figure out what's the best match history for this extra step, right?
Right. And that could be either a shell, which represents just a device.
Right.
Okay. Right.
A set of devices, which represent the same function on multiple shells, or multiple devices, multiple regions.
Yeah. And then,
Or just a single, yeah, those are the only two.
and then
The user could ask for a shell or device. I could ask for a function, I could ask for a bit stream. Those are things which are potentially possible in extra specs, right? When it goes to cyborg and comes back, all the filter can do is reduce list of hosts. You can't do anything else. So you give a list of hosts, can say, out of the 100 again, you only use 20 fit. It does reduce it. That's all that the cyborg API is going to do.
And then after we figure out which UID to use, it will call this API to load it onto the API.
So
So
that's the last step. What we're talking about is filtering and making some controller, right? That doesn't do any programming yet.
yeah, that's just figuring out what to use, right?
Uh-huh.
Right. And then how to use this API, like make it use this.
Yeah. Okay.
Right?
Compute mode stuff. Okay.
Yeah. So that's actually probably another scope, right? We have a service to figure out what translate the function request from the user into the bitstream that has to be used for the request. That's another level of magic.
But I think that if we could do that, just start on that. Maybe the initial, it just is one-to-one. You don't have any more
Right,
options, but there's still a translate layer.
Yeah.
It could be extensible.
Yeah.
Because I see three different things, if you will, in opening here. There's the bare device, a bare FPGA without anything programmed on it, right?
Yeah.
So when you request that extra spec in that flavor, it's going to go find a device level. It's going to go search for a device. It may not be a PCI device. It could be any kind of device.
Yes.
But it's somehow cataloged as an FPGA.
It's
Either by
usually
JTAG or something.
Sure.
Then it flashes that device over some other interface, whether it's Ethernet, whatever, or JTAG, or virtual something. I don't know.
Why
Virtual
is
PCI.
flashing involved in this scenario?
Because the user may want a bare metal, FPGA bare metal experience, if you will. This is not the cloud native flow, by the way. This is just something that is possible. Say if you're updating your shell.
Okay.
Yeah.
Is that going through OpenStack as well?
Possibly.
Oh,
Okay,
yes.
Okay.
well,
Okay.
it doesn't have to go back to OpenStack, right? It's a cyborg provides API.
Whoa, okay, so cyborg.
The cyborg can shop like
Yes, yes.
as long as you know what.
Right.
Yep. And there's pause. You can start the instant pause, wait for that to happen. If it's over JTAG, it should take some time. Well, it depends on how you do it. But okay, so that's one flow. The other flow is if you have just a one-to-one bit stream mapping, right? You just want a bit stream, you don't necessarily identify. So when it goes and looks up that UID, it says, oh, there's only one. There's only one.
Oh, yeah.
Then there's the function where it goes and it goes, hey, I actually have three possible options here.
Right.
Now I have to make a decision.
Which one to choose?
Which one to choose?
Or at least which one to rank higher.
Right. Which one to rank higher?
And the other
And that
one would
one-
be
That is that's the fear. So you have the bare metal kind of experience, the programming of the shell. You have the one-to-one mapping, and then you have one-to-many mapping.
apart from the shell, the user will ask for just the empty region, right? The empty device. The shell is already present. Somebody already programmed it.
I would
They just
say-
want the area to just
I would say that falls under the one-to-one.
Yeah, because you have only one possibility.
instead
Right?
of asking for a bit stream ID, asking for some kind of
Some
device or
device,
region
just
ID. or
return
whatever.
me the device,
Sure.
Yeah.
which is a shell ID.
Okay. Okay. Cool. Okay.
So can we build it, even if we only do the one-to-one now, we don't even need to support the JTAG bare metal. If we could just do the one, can we do that in this scope? Do you think that's possible?
In Rocket Pro?
Yeah. So that we could extend it later
Yep.
without ripping it all.
We can start an API,
Okay,
but at least have an API there.
okay,
And then make sure the flow works.
yeah,
And then, yeah.
okay. So somehow, I guess we need to get that down. I think it's important because there's a lot of different ways we could run an OpenStack cloud, right? You could run it as a public cloud. You could run it as a private cloud, or you could just run it as dumb infrastructure that just programs FPGAs every once in a while with some functionality.
So you're considering the possibility that one image will this program express multiple PFs or VFs, and that's expressed in topology, right?
Correct.
Yeah.
Okay. So who actually implements that thing? So is it vendor driver or cyborg itself?
Vendor driver.
Okay. So you actually
Vendor should parse that topology out and then report it.
okay.
Yeah. Because you retrieve this metadata and download. The driver knows what this topology will look like after the distribution is loaded.
Maybe I'm missing something. So you program one image, that's just, let's say 5 years. Each of those corresponds, let's say, a different accelerator.
Right.
Okay. How would the user ask for one of those accelerators? That's the function. Maybe I'm missing something there.
Because you load the stream that gives you 5 accelerators.
Right.
You report it to cyborg.
Uh-huh.
Cyborg has them in their database.
Yes.
Reporting placement. And something like that, right? And then as long as cyborg knows, right? Cyborg can do the cyborg stuff too.
You just got description of the model. We are not reporting individual accelerators placement anymore on the previous session.
Right.
Only device types get reported.
Yeah, but you know that there's some new type of the resources that's logged inside. That has to be reported. Right.
So where on the flow does this fit? I think this fits in the kind of user. What will be passed through the guest, right?
Yeah.
This is what the guest will experience.
Yeah.
Right.
So we load this IP. That's one step. That's done.
Changes
Load it. And then the other path is the resource tracker, right? The resource tracker just scan these devices and figure out what's in there and then go to cyborg DB. And this triggers the entire flow, including how to update it.
So in the 5 years it got created, let's say doing 5 different things, A, B, C, D, and E.
Mm-hmm.
How does the user say, give me function C? What does he put in the flavor?
Is that even possible?
Yes, that's a functionality thing that we're talking about.
Well, because
it's not image.
I know, but I'm saying with this. With this
one, I don't see how it will work. Because you're asking for image, we're getting an image, but the one image corresponds to 5 different things. What the user asks for only one of those things.
So for here,
I think that might fit into another flow. Right now we're just talking like a trivial. All this is only just to provide the information to the guest.
So
you would only put the one, you have 3 in here.
You have only one VF and only one function, you're done. No problems there.
Yeah.
So here, HPF or VF has its own capabilities. It's mentioned in here.
Okay.
Yeah. So
Can
this
please make it bigger. It's difficult for me to read that. Okay.
Just present mode maybe.
Okay, cool. That works. Okay. So capability.
Yeah, and KPI, whatever, because this piece can be vendor specific or distribution specific.
This is part of the topology.
Yeah.
The cloud.
Yeah, the topology.
Is this a UID of some kind?
Sorry?
Is a capability field a UID?
It's not UID, so could be RSA, could be EpiSec, anything, right?
It's a string, okay.
It's a string. And then the driver reads this and then report what this VF or PF can do to cyborg. Now cyborg can decide, okay, what the user wants and give it to the user, right?
So in the flavor itself, you have to express that string, the IPsec or
Sort
whatever
of.
it is.
Yeah.
Okay.
Yeah. Because in the flavor, it tells cyborg what you want, right? And this tells cyborg what you have, right?
Mm-hmm.
And cyborg decide what to give you, right?
So cyborg is gonna parse all this metadata.
Well, the vendor driver parses this, and then report to the resource tracker, right? The reporting API we standardize it, right? It has to follow this reporting schema, but it's up to the vendor how to interpret this information. Yeah. Well, vendor could have their own magic in here. I don't care. It could even not. You could not. You can even use XML if you want. Right?
So this is specifically for the vendor driver.
In my vision, it is.
Okay.
Yeah. At least for now.
Is it optional?
Well, it's totally optional if you want. It's just guiding how you report, how you guys report this stuff, right? You can have your own ways of reporting stuff.
Yeah, well, yeah, that's what I'm thinking if it's just,
Well, from cyborg point of view, you just do a report. And then I got the stuff you reported, but I don't care how you report it. You could even go somewhere else and gather information. I don't care. Right.
I think this makes sense. You need something like JSON.
Yeah, we definitely need something like this. Otherwise, it's too generic. Like each functions, each IPs, and creates different topologies of VSPS, and there's no way we can track it in a relational database, right?
The only thing that makes me think is like if it's an arbitrary string for capability, how do you ensure that two different vendors are not colliding? There are two different images.
Well, we have other metrics, right? We have here we have vendor and more in child ID, right? We can defer them, but we already can defer them from here, right? It's already been deferred.
and
It will enable different vendor driver just based on that.
so okay, so the vendor driver provides that metadata, right? That cloud. What does cyborg do with it when it gets it?
Well, cyborg doesn't get this cloud. Vendor driver gets a cloud, and then parse the cloud, and then report. And then the report should be in the cyborg language already, like deployables or PFVs, right? Using those data structures.
That's the cyborg vendor driver, right? Parse the cloud.
Parse the cloud.
So when a cloud operator gets this image, he has to go to the topology field, extract those capability strings, and create flavors out of that. That's what it is, because the flavor has to refer to that particular function eventually, because that's what the user is asking for.
Right.
So the cloud operators create such flavors.
Well, cloud operator at least he should know what to put into the flavors, right?
Yes. Right. It comes from this field.
Well, yeah.
Wait,
Or this and the flavor can come from some other sources. Like, for instance, one example I can give is you create this bitstream, right? This group, and the developer knows what this bitstream can do, right? And he wants to publish this one to the cloud to make money out of it.
Yeah.
Now we provide a utility or setup wizard, right? And then ask him to fill in some blanks.
Yep.
After he filling these blanks, image gets uploaded. This gets created, and flavor gets created. And that way we can ensure those mix matches. Right.
Okay, so basically cyborg API will generate flavors as well.
Right. Well, at least it should guide.
Wait a sec. It's generating flavor.
Well, at least it should give some guidance on how to create a flavor, right?
You should just create an image.
Yeah, it uploads the image, you're right. The image contains topology field, which indicates the functionality inside.
I know, but now we're talking about the public cloud. So I just want to clarify the things that you've been talking about for more infrastructure in place. Because you have to define a flavor. You don't want flavor explosion. That's the last thing you want, right? So if you're defining your functionality in a flavor, that's a no-win in a cloud. It's no win in a public cloud where you're selling things. You need to define a generic infrastructure, right? Like I want a VU9P. This is just a large FPGA. And this bitstream will go onto that VU9P, and it's already been adjusted and everything, right? Metadata is good. Now, when I publish my image, it gets published also optionally with the OS image, right? You can bind them, right? Nova allows you to do that.
You mean like you wanna CentOS or
yeah? So you build your environment with your deployable,
right?
So the OS image contains a reference to the image for the FPGA image, right? And then when you start it, you have, and it depends. So when you start it, you only refer to the flavor type that it's compatible with, which could be anything with the VNFP. Right?
But you still need to tell OpenStack what you want. Like, you want IPsec or you want
No, you just tell it I want this device.
Oh. then
Just tell them I want this device and everything else is
that's
handled.
totally fine. That's totally doable in this scenario. Like you want, because it still has board and this information here, right? Where you do the filtering.
I know, but I'm saying the ingest flow should not go and create a flavor for you.
No, it's not. It's not creating the flavor for you. It's just provide some information for the admin how they gonna create this flavor. It's like
Okay.
yeah, right. It may have a
cyborg doesn't.
maybe have a cyborg
So that's an
accelerator list, and then you just list out all the
Yeah,
capabilities
okay.
that you have, right?
That's
And then the cloud admin will go and okay, I can do this, and that, and then I just create a flavor and you
Okay.
use it.
Yep.
I'm not saying they will go to Nova and do the Nova flavor create. No, I'm not saying that.
Okay.
Yeah.
So, we're getting close, I think. Sorry. The last thing, I guess, I'm still a little confused about the clob still. Topology.
Maybe the naming is not perfect.
No, it's fine. It's just I'm trying to figure out how it's actually used. Where is it used? You know what?
In the driver. It's mainly for.
So it's used in the cyborg vendor driver.
Yeah.
And what does the cyborg? What does it do? What does the cyborg vendor driver do?
Do two things:
generates it?
discover and program. Right. Two things. Right. Two APIs. Discover and program.
And you're telling me it's going to discover
Think of this way.
the functionality based on a bit stream?
Yeah. Because you load the bit stream on the device, it changes the behavior of the device. It gives some functionality to the device, and you need to figure out what the functionality is. Unless you can specify this functionality in your PCIe bar space, that's totally another option for you, right? You in the bar space, you write, okay, this PF does this, and that, right? And then the next PF does this.
Yeah, but
Then that way you don't have to do this.
So in my use case, so the scenario that I run, the PF doesn't change, right? It's just the user PF. It's always generically a user PF.
Mm-hmm.
I can query inside of the FPGA. There's some registers that I can read that have metadata about this compute units.
Mm-hmm.
And I put compute units in there up to 100 or 64 compute units. They could be one thing, and they could be many things.
Mm-hmm.
So I guess those many compute unit functions need to be passed through to this metadata file.
So that those information will change every time you load the stream, right? That's what you say.
Yeah, and it's up to the user application to know how to address those things, right?
No,
the driver is the same all the time.
That's the driver to know what's in
No,
there.
because it's a function, right? I just call it.
Well, yeah,
it's
it's a function, but the driver loads those information and then translate it to functions and then save it in the database.
No, it's all in user application space. It's all in the user application space. It's not in the database. Cyborg has no knowledge. It just puts the image there and that's it.
Okay.
There's one user function. That's it.
Oh yeah.
And the application that you ship within your OS image in your environment, application environment, or your container, whatever you want to do, that has all the information about the functions and it calls the driver and the hall and everything to actually write.
Let's say image-based program. Okay? If there's only one simple thing, driver can read something inside that program logic, like register or something like that, figure out what it's going to do. It's something more complicated, like what he's talking about. It generates multiple PFs and BFs. For a driver to generically discover what the program is actually doing, it needs some metadata, and that's a topology field.
Mm-hmm.
It's basically describing the PF structure and how it corresponds to the program logic. It's a generic way.
Yeah, and I understand that, and I'm trying to figure out because I have a very generic form of this.
Okay.
Whereas Intel with OP8, you have a different form. You can have many different things and all this stuff. I only have one PF. And it's just a user PF, but inside that PF, all my functionality is in there. Mm-hmm. It's at the application layer. So would I just expose a one user PF in that metadata?
Yeah, sure. Yeah, sure. Yeah. You can do that. I mean, in that case,
I'm trying to figure out what consumes this topology. Is it the
Well, you can.
It's a generic vendor driver. to operate this class of
Yeah.
images or devices.
Because if you like, your driver can just totally ignore this. It's
Yeah.
fine. If your driver has different ways of finding out what.
You mean
this,
if the device didn't change at all, just ignore it.
yeah, just ignore it.
Because it'll be the same as it was when it was.
Yeah, just ignore it.
Okay.
Yeah.
Okay. All right. That's fine.
Yeah, this is for
I was just
more.
trying to figure out if it's required. If it's required, then you need to understand what it's defining to who.
You can make it as simple as you want.
Okay,
Single
yeah.
key of your run. That's it.
Yeah, this just give you
Just fine.
this all
Whatever
this
it
this information, like this cloud will go to driver, right? And the rest of information goes to scheduler when they try
So
to
the
find
reason
out.
why this is done, then, I guess, is because after you program, you could have multiple VFs just pop out.
Yeah.
And then you need to pass it in to the guest,
Right.
right? And that's what this data is used for, and the vendor driver can then communicate that information.
Right.
Exactly.
Okay,
Right.
got it.
Yep.
Okay, sorry. Understood.
Okay,
Okay,
that's it for me.
great
So
discussion.
yeah, so I'll add the bistro, like the UID stuff,
Okay,
and then write some
API.
yeah